Hello again. Welcome back to GSCE Labs. I know I said that we'll be waiting until Monday to make the first lesson. However, I just decided to have an early start just to be ahead of schedule and just give you the first lesson in biology, which is going to be on microscopy. Really simple, really straightforward information, and hopefully you absorb it into your heads and is fully obtained. Using units, please make note of all these 5 conversions plus how you convert 1 nanometer into standard form, because in GCSE maths and science standard form is highly used and is really prevalent. So please make note that 1 nanometer equals 1 multiplied by 10 to the power of -9 meters, and these should be fairly straightforward. You can make notes. 1 kilometer is 1,000 meters, 1 meter is 100 centimeters. These should be fairly straightforward from the top. For these first 3, just make note of these 2 if you don't remember these. Now, because we're talking about using microscopes, it's important to know this equation. Image size divided by magnification equals real size. So what that means is the size of how the specimen seems to look through the microscope divided by the magnification level, which is usually written like this, for example. Don't know if you can see that because that's in red. Yes, that's how it's usually written as. Will be giving the real size. So it's the actual size of the specimen. So and this usually works with the width of the specimen that you are observing through the microscope. So please make note of this equation as it always comes up when it comes to cell biology. Now let's try this. Read the question, pause the video, and we'll go through the answer together. Okay, so now we will see that we can identify that 85 micrometers is the actual size. So let's actually just write the equation from memory. So image size divided by magnification, I would say m equals real size, right? We can array, and they say if the magnification level is multiplied 100 or times 100, how wide is the image of the specimen? So that means we're trying to calculate the I of the equation, and it's really important in science to know how to rearrange the equation. So we'll be doing I equals magnification level multiplied by the real size. See, it's the same equation, only it's just rearranged. So magnification multiplied by real size will give you the image size. So now we can start to substitute these values. So 85 micrometers, so that's the real size. So I'm just going to put 85 there. Just going to add the units as well, just so, because we need to convert it into millimeters later on. So I'm just going to put micrometers here, right? Multiplied by magnification level. So that's 100. And that gives 8,500. And they want us to convert into millimeters. So yes, we do still have to put the units here because we haven't changed anything. And we know that 1 millimeter is equal to 1,000 micrometers. So we can use multiplicative reasoning, which is a really advanced math skill. Not too advanced, but it just works with balancing each side out using measurements. So if 1 millimeter, sorry, not 1 meter, 1 millimeter. So if we do 8,500, micrometers. Sorry, that's a terrible 0. Let me correct that. There we go. Then what did we have to multiply to get to here? Well, we had to multiply it by 8.5. So we do the same thing here. Multiply by 8.5 and we get 8.5 millimeters. So the answer, so I'll just put answer should equal 85.5 millimeters. And there you go, that's how you work it out. So you should know how to rearrange the equation, you should know how to substitute the values in from the question, obtain the answer, and then be able to use multiplicative reasoning to actually get to your answer, knowing how to convert your units. Fairly simple. So these are the key points about microscopy, and make note of the definition of resolution as well, the ability to distinguish between 2 points. Thus, a higher resolution provides a clearer image. And you should know these spec points, so the use of microscopes developed over years as technology and knowledge have improved. So technology and knowledge are keywords. All the keywords are highlighted or in orange. So it talks about light microscopes and electron microscopes. So if we read here, light microscopes use light and lenses to display an image of a specimen, and magnify, so try to avoid using the word zoom in because that's not really scientific. You say magnify to enable us to see individual cells and large subcellular structures. Electron microscopes use electrons, so electrons, not light and lenses, electrons, so I should just give it in the name, electron microscopes, to display an image and have much higher magnification than light microscopes. Higher magnification, so this means that you can see the image clearer, and a higher resolution. So electron microscopes let us see much more miniature things in detail. So a high resolution means a clearer image, because that's in the definition. A higher resolution provides a clearer image. Also, what I didn't include here is that light microscopes are portable. So, oh dear, I'm terrible with using a mouse to draw, or write rather. Portable. Portable. So this is not portable. And also, electron microscopes are much more expensive than light microscopes. So I'll write expensive. So make note that whatever I'm putting, it should be the opposite for the other microscope. So if this is expensive, then that is cheaper. Not cheap, but just less expensive. And if this is portable, this is not portable. Okay, so the microscope structure. So this is what a typical microscope looks like. This is a light microscope, because if you read here, there's a light source. And we should know these parts by heart. And usually it says here stage, right? There's also a slide here. There should be a slide. This is where the specimen is actually located. There's objective lens, an eyepiece lens. We'll go over these parts, the coarse focusing wheel and the fine focusing wheel. So just familiarize yourself, pause the video and maybe make a diagram of this and label diagram, so you familiarize yourself with what a microscope looks like. Okay, so these are the microscope parts. So according to what we've just seen, there are functions for each of those microscope parts, and it's really easy to remember them. So the eyepiece lens is simply what you look through at the top of the microscope. These are, an objective lens are the principal optical lenses of a microscope. The fine focusing wheel, this component moves the stage by only a bit to focus on the image further. And the coarse focusing wheel, this component moves the stage by a vast amount in order to obtain and focus on the image. Stage, a platform used to place the specimen and observe it, and usually it comes with a slide, so just write slide here. Light, so remember it's a light microscope that we're talking about, a source that allows the specimen to be viewed through one or more lenses. So remember, use light and lenses. And please do make note that an eyepiece magnification multiplied by objective lens magnification equals total magnification. So if this is multiplied by 20, and don't really make note of this, I'm just giving you an example, and this is times 50, then that will be giving you the full magnification, so that'll be 1000 for the total magnification. Usually we have to use two equations in one question, usually in like really high level exam style questions. Anyway, I hope you've taken a lot from this. This is just acting as a review for studying microscopes as your first biology topic, and see you next time.